Hi everyone, welcome to Full Stack Mania. So today we are going to learn how can we integrate GraphQL with a Spring Boot application. Before that, let's understand what GraphQL is. So this is the official site of GraphQL. Basically, GraphQL is a query language for API that allows the client to ask for the specific set of data they need. In the diagram, the profile service is having a single endpoint called /profile, and this endpoint is returning 10 fields in response. So all the three clients will get all the 10 fields when they will call this profile service. In a nutshell, REST API returns fixed response for a single endpoint. What if our requirement is something like this, where each client needs a specific set of data? Like client 1 needs name and email, client 2 needs phone number and employee ID, and the client 3 needs only the location. That's when GraphQL comes handy. Let's understand the control flow of REST API and GraphQL. In REST API, the entry point for the application is the controller. The controller will call the service, and the service will call the repository, where we extend our repository interface from JPA repository or CRUD repository, and JPA will take care of the database layer. In GraphQL, the entry point for the application is the query, and that is the only difference. There is no difference, as you can see, and there is no impact on the repository layer. Let's jump into the IDE and start writing our first GraphQL application with Spring Boot. Here I have created a basic Spring Boot application. So let's go to the pom.xml. Here we have only two dependencies in the application. One is the Spring Boot Starter Web and the other one is the DevTools dependency. Let's add the GraphQL related dependencies to the application. We have added two GraphQL dependencies to the application. One is the GraphQL Spring Boot Starter and the other one is the GraphQL Java Tools. Now let's write our first query. To write a query, let's create a class. Let me put it in a separate package and create a class called query. And let's annotate this class with @component annotation so that it will be in the Spring Boot radar. In REST API, we annotate the controller class with @REST controller annotation so that Spring Boot gets to know that it is not a normal class but a controller class. Okay, so to do so, here we have to implement the query class from GraphQL Query Resolver interface. Let's write a method that will return simple string as the output. In REST API, to make the method a consumable endpoint, we give mappings to it. Basically, mappings will define what is the HTTP operation and what is the URI to which client can send the request. In GraphQL, the entire application runs on a single endpoint, and that is by default /GraphQL. So here, to make this method a consumable endpoint, we have to define schema for it. So let's write our first schema. To do so, create a file in the source main resources. The file name can be anything, but the extension should be .graphqls. And if any file is there with this extension, then Spring Boot will pick it up. Okay. Let's understand what schema is. Basically, schema defines what is the name of your query class, what are the methods inside the query class, what is the return type of the methods, and if any method input arguments are there, then what is the data type of the method input arguments. Let's follow the syntax to write a schema. Here, the type name should be matching with the query class name. As our query class name is query, so let's write type query. If you give anything that is not matching with the query class name and you start the application, then the Spring Boot application won't even start and it will give errors. Let's define the methods inside query class. So as you see, we have only one method inside query class. So write first query and the method is not having any input argument. So let's define what is the return type of the method. So as you can see, the return type of the method is string. So let's write it string. With this, our first GraphQL query is ready and we can consume the query we wrote. Okay, so let's test this. Let's run the application and we'll test it with Altair GraphQL client, that is a Chrome extension. So our application is running on localhost 8080 and /GraphQL is the default endpoint. So let's click on the refresh button and go inside the docs. Now we can see our query, and if you go inside the query, then you can see the fields inside the query. Basically in our case we have only one field, so it is returning the first query. To consume the query, the HTTP operation will be post. In the request body, send the query class name. You can see the autocomplete here, and inside the query class write the operation name that you want to fetch and click on the send request button. Here you can see we are getting the response back. So we are done with our first query. Let's understand the response. Here data is the root element under which operation name and operation response will be key value pairs. Now in first query the response is string, so we are getting a string back. If it would have been a custom class, then we will get JSON as the response. Now let's write another query and understand the role of schema in GraphQL. So I will write another query and change the name of the query and restart the Spring Boot application. Here we have defined the query at the class level, but we have not defined the query in the schema. So let's go to the Altair plugin and see what is happening. So let's refresh the documentation, and after refreshing it we won't see the second query in the fields. The reason is we have not defined the second query in the schema, and even if we try to send the second query in the payload, then the autocomplete is not going to work and we will get some errors. Here it is telling that you cannot query the second query field on the type query. To fix this, let's define the second query in the schema file. So the method name and the return type of the method. Now restart the Spring Boot application. As we are using DevTools, so Spring Boot will restart the application automatically. Now refresh the documentation and we can see the second query in the documentation. And if we send the second query in the request body, then we can see the response as well. In this video, we are returning string in the response. In the subsequent videos, we will see how to write schema for custom Java classes and how to return custom Java classes in the response. Thanks for watching guys. Thank you.